This is instructions on how to do work lab number 1. The purpose of this lab is to explore and compare different ways of determining the work done. The variables, we have an independent variable, which is the method used, and the dependent variable, which is the work found. Now we need to take a look at the equipment we're going to be using. You're going to need to gather up a protractor and a ruler, a Pasco car, a piece of Velcro, a string loop, and a Pasco ramp. In addition, you're going to have to gather a USB link, which is this guy right here, and a force sensor. Be sure when you get the force sensor that you grab one with a hook attached. Once you get all this stuff gathered together at your lab table, go ahead and set the ramp up so one end is on one of the cubbies. So up here we can see it stuck in there. Notice it's not sitting on top of the computer, which should actually be out because you're going to be using them. The other end down here is braced by a book. The book should both support the ramp and keep the car from sliding off the ramp. As you get the ramp set up, the next thing is you're going to take the Velcro and you're going to make a loop on it and stick it onto the sticky piece of Velcro that's on the car. Then you're going to take a string loop and pass it so it's inside the Velcro loop. Next, go ahead and turn your computer on and log in. This lab is going to accomplish 3 separate types of things. The first is you're going to calculate the work done as you pull the car up from the bottom to the top of the ramp. And you're going to need to eventually create a procedure and analysis section. The analysis section is the calculations from the summary of what we're doing in the lab, and I'll tell you some more later. The second part, you're going to calculate the theoretical work done going up from the bottom of the ramp to the top by using the mass of the car, the angle of the ramp, the distance traveled, and the formula. And again, you're going to need to create a procedure on that. And finally, you're going to calculate the work done as you lift the car up vertically to the top of the ramp. So that's a big overview of what this lab is going to be. 3 separate parts. In each part, you're going to be calculating the work done. Only you're going to do it a slightly different way. Taking a look at the first one, you're going to calculate the work done as you pull the car up from the bottom to the top of the ramp. In order to do this, you need to hook up the USB port and the force probe and open up Data Studio. Okay, we're going to take a quick look at Data Studio. I've got my USB link plugged into the computer. I've got my computer screen on, that's real important. And then, at this point, I now plug in the force probe. And this pops up. This time we want to go ahead and launch Data Studio. So I'm going to click on Launch Data Studio. I don't really want to have a graph, so I'm going to close the graph. Okay. And I'm going to go down here in the lower left-hand corner, click on Table, grab it, and pull it up to the force probe. So the force probe turns a little gray color, and I let go, and I've got this table. Okay, now I'm going to take the force probe and hook it onto my car. And I am pulling the car up, and I hit start, and I collect data. I collect it for a while, and then I'm going to stop. Okay, now I've got quite a bit of data. I can make this bigger, move this up so I can see all the data. I want more precision. I want to see it to the hundredths place. So I'm going to go up here where it says increase precision and click on that. Okay, now I've got a whole bunch of numbers here. I want to find the average number, and I could calculate it, but it's just as easy to let the computer do it. So I'm going to find a place where I'm reasonably consistent, just highlight a bunch of them. So I'm going to go about here, and I'm going to grab these, and I'm going to highlight all of them. Okay, so I've got a bunch of data highlighted. Nope, don't want to go there. I go over here where it says Statistics, Show Selected Statistics. I click on that, and down here I've got the mean. The mean is my average force. Now it's showing a negative number just because of the way the force probe is set up. I'm going to make it positive because I know I was pulling up, and up is positive. So the mean is my average. So the average force I used during my entire distance that I traveled with the car is 1.84 newtons. So you're going to find the average force you used to pull the car, whether you're pulling it up the ramp or whether you're pulling it vertically for the other part of the lab. And that's all there is to that. Eventually, you're going to write down your average. You don't have to copy all of this data. All you need is your average, your mean, 1.84 for me. And when you finish all this, you can click out. When you do your next run, just go ahead and hit start, and it'll have another run going for it. And you'll do the same thing with that. If you want to delete data, if you get too much going on here, go under experiment, and you can delete the last data run. Okay. Or you can delete all the data runs. Okay. Once you get all that done, you want to make sure you start the car at the 10 centimeter mark. It's hard to see in this picture, but the car right here, the back end of it, is at the 10 centimeter mark. And likewise, when you end pulling the car up, you want to make sure you're at the 80 centimeter mark. So again, this is the back of the car, and the back of the car should end at the 80 centimeter mark. So you're really pulling it from starting at 10 centimeters up to 80 centimeters. So you're pulling it a total distance on the ramp of 70 centimeters. While you're pulling the car up the ramp, you want to make sure that your force probe is as level as possible with the ramp. So you can see here I've got this one red line indicating the ramp being level, and here is a line from the car to my force probe, and that line is very much in line or parallel to the ramp. You want to keep that force probe as parallel as possible to the ramp. That allows us to keep the angle between the force and the distance traveled at 0 degrees, which is really important. So again, be careful to keep your hand on the force probe parallel to the ramp. Measure the distance pulled. Find your average force on Data Studio, and then use work equals force times distance times the cosine of theta, where theta is 0 degrees. Next, you're going to do it something slightly different. You're going to do a theoretical vertical work done going up from the bottom of the ramp to the top. And you're going to do this using the mass of the car. So you're going to have to mass the car. You're going to find the force of gravity. So you're going to use Fg equals m little g. Be sure to use 9.8 for little g. You're going to find the vertical distance traveled by using the angle of the ramp and some trig. And you're going to find you're going to use the formula work equals force times distance times cosine theta. And again, since we're using a vertical force and a vertical distance, theta, the angle between force and distance, is 0. And of course, the cosine of 0 degrees is 1. To find the angle of the ramp, you're going to put a protractor down, and mine isn't lined up very well. I really should have had this dot right with maybe this point right here that's easy to see. Okay, so I've got an imaginary line drawn here so I can find exactly from this dot to where my angle is. So you're going to do that with your protractor and your ramp and find the angle the ramp is at. The third part of this lab is to calculate the work done as you lift the car up vertically to the top of the ramp. So this is actually pretty easy. You're just going to lift the car up. The only trick is you have to make sure you know the distance from the bottom of the table to the top of the ramp. When you calculate the force, the average force being pulled, it doesn't matter if you actually pull the car up that distance. Just pull the car up for a ways to calculate the force that you use to pull it up. The tricky part on this is measuring that distance from the top of the ramp to the top of the table. And you're going to want to do that from the 80 centimeter mark on the ramp. So you're going to find that 80 centimeter mark on the ramp and measure from 80 centimeters down to the table, finding out how high that is. Once you've done that, it's fairly easy to calculate the work done. So now you've done three things. You've calculated the work done as you pulled the car up from the bottom to the top of the ramp. You've calculated the theoretical work done going from the bottom to the top of the ramp by measuring the distance using some trig. And then you calculated the actual work done as you lift the car up vertically to the top of the ramp. So you've figured out work three different ways for basically the same ramp and the same car. Now you're going to compare all three values you got for the work, and the way you're going to compare them is using the percent difference between them. So you're going to compare the value of the work between part 1 and part 2, and you're going to get a percent error for those values between 1 and 2. You're going to look at the numbers between part 2 and part 3 and find the percent error for those numbers. And then you're going to do the same thing for the values from part 1 and part 3 and calculate their percent error. And the percent error, really, since we don't have a known value for this, it's really a percent difference. So we're going to use the percent difference formula instead of a percent error formula. And that percent difference is shown right below there. Write it all up and hand it in. Thank you very much for your time.